Hi, my name is Sergey Sindakovsky. This is a final project for CSCI E90. This project is going to explore two core use cases related to translation and speech synthesis. It will utilize following services we already used in class: SQS, SNS, DynamoDB, Alexa, Lambda, EC2, CloudWatch, S3, and IAM. The two services that we have not explored, AWS Translate and AWS Poly. Let's look at the architecture diagram for the use case number one. It consists of a Python script that pulls via API a random fact in German from the services called randomuselessfact.com. Let's run the script. We could see a random fact being generated. After random fact has been pulled, it is sent as a message to an SQS queue that gets queried by CloudWatch every minute. After consuming the message from the queue, CloudWatch passes it to the Lambda, AWS Lambda, that performs several actions. First of all, consumed message is being passed to AWS Translate, resulting in random fact being translated into English. Upon successful translation, the original message is being deleted from the queue and sent to the SNS topic. SNS topic has one defined email subscriber that sends an email with the translated message to the desired email destination. Since we executed produce.py more than a minute ago, email message should already be there. Let's take a look if desired translation has been delivered. And sure enough, it has. Okay, let's look at translate Lambda function in more detail. It's fairly simple code that's been executed by AWS CloudWatch every minute. It pulls the message from the specific SQS queue. Lambda code assumes that the message that's coming in is in German and it's going to be translated into English. In production conditions, no such assumption would be made, and the actual language and the desired outcome language would be passed as part of the message. Message in German is being passed to the translate text method of the AWS Translate service right here. Appropriate log messages are being logged for debug purposes. After that, translated message is being published to a specific SNS topic. If we encounter no errors, original message is being deleted from the SQS queue to avoid double processing. It is important to note CloudWatch settings. Let's take a look at it in more detail. It is important to note CloudWatch configuration. Schedule expression depicts execution frequency, setting it to every minute. It should be enabled to start an execution flow. Okay, let's look at use case number two. Use case number two utilizes Amazon Alexa. Let's find an appropriate Alexa skill we developed for this purpose. Here it is. It's called Sergey Speak. Let's invoke it. Alexa, start speak.
Welcome to Translate. Please request the language.
Alexa is asking what language should we use to translate our sentence to. At this point, we only support two choices, German and Russian. Let's choose Russian. Language is Russian.
Please request translation.
Now Alexa wants us to say text we want to translate. Translate, this project is great.
I translated this project as great.
We got the confirmation that our sentence has been translated correctly. Let's take a look at the flow. As we're interacting with Alexa, AWS Lambda function is being invoked. It stores desired language in the DynamoDB and translates our sentence using AWS Translate. After that translated message is being fed into AWS Poly for speech synthesis. After successful synthesis, translated voice file is being stored on S3 bucket, and the reference link is being sent to SNS topic that delivers a link to the user via email. Let's take a look if it is there. And sure enough, it is. Let's try to click on it. Translation is being downloaded.
Этот проект отличный.
We can hear the translation. Trust me, it says this project is great. Okay, let's take a look at Sergey Speak Lambda function in more detail. It is much more complex function compared to Sergey Translate Lambda. It's being invoked by Alexa skill. Let's pull it up. Here it is. Alexa skill consists of two custom intents: get query data and get language data, and the number of built-in intents. Our Alexa skill is using two built-in slot types: search query and the language. Search query takes any input, but must be preceded by the word translate. Language slot takes any AWS supported language. Going back to the Lambda function. After being invoked by Alexa skill, first and foremost, we need to determine what translation language is being requested. We make an assumption that the messages are coming in from Alexa in English, but the destination language needs to be determined. This bit of code does that. We need to pay special attention to the voice ID, since AWS Poly requires the language to be matched up with a voice persona for the speak synthesis. After language and the voice is being determined, it is being saved in DynamoDB to be extracted during translation intent execution. We could see it in DynamoDB table. Just as it is the case with Sergey Translate Lambda function, we translate passed-in text into the language we collected and stored during language intent execution. At this point in the execution flow, we're also preparing for the message to be synthesized by AWS Poly. Here's the synthesized speech code. If we got no errors during the execution, MP3 file containing synthesized translation is being passed to the S3 bucket. We could see it right here. Going back to the Lambda function, location of the MP3 file on S3 bucket has been published to a specific SNS topic. We're reusing SNS topic from the use case number 1. As a reminder, SNS topic has a single email subscriber. However, unlike use case number 1, delivered message does not contain translation directly, but rather a link to an MP3 file that can be downloaded. Here it is again.